Hello everyone, welcome back to ENR 123 tutorial videos. Today we will be building the axle. So as you guys can see on the screen, we have the E drawing open. So it's a pretty simple part. It's a cylindrical part. One thing to point out is we actually have a dual dimension on some features or some dimensions. So the number in between the brackets is actually the dimension in millimeter, and the overall unit is in inches. So the diameter is 0.236 inches, which is 6 millimeters. So you can actually show that in SolidWorks. It's a nice little feature. So let's jump into SolidWorks and build this part. So I already started a file and I called it the axle and I saved it in my folder. So you can do that before or after. And I already set up my parameters. So it's in inches and my document units are 3 decimal points. So I already went ahead and did that before. So the drawing calls out for a 1018 steel. The closest material in SolidWorks is actually a 1015 steel. So I just went ahead and chose that. And when you run an analysis or anything like that, if you decide to, it will give you similar results as if you were actually using a 1018. It's a very similar steel. So I'm just going to go ahead and start a sketch on the right plane. And I'm gonna sketch a circle. And I'm gonna use smart dimensions to dimension that. So it's 0.236, and that's in inches. The other nice thing you can do, so from the drawing, you know that this is 6 millimeters. So if you actually go in and click, you write in 6 millimeters, it automatically switches it to inches since our document calls out for inches. So my sketch is fully defined. So we can go ahead and extrude it. So this is important. So since we started a sketch on the origin and I want everything to be symmetrical, so when I mirror one feature about the midplane, mirrors perfectly on the other side, I want to make sure that my direction 1 is midplane. So whatever the overall dimension I'm specifying is actually going to be divided by half, one extruded from the right side of the plane, one extruded from the left side of the plane. So it's symmetric about that plane. And that's 6.5. Perfect. So I'm going to go ahead and add my chamfers. So the drawing calls out an angle distance chamfer. So I'm going to go under features, there's my fillet, go to the drop down menu, select chamfer. So this one is the angle distance one, the one we will be using. This is the distance. There's a vertex, an offset face, and a face. So there's a lot of types. So for this one, we're just going to use the standard angle distance. The items to chamfers are the 2 edges. So I'm going to go ahead and select my edges. I'll have full preview toggled on. My distance is 0.031, which is 1/32. So I'm going to go 30 seconds of an inch. My angle is 45. So I'm going to go ahead and click check. Perfect. We got our chamfers in place. Rotate it. So I'm gonna go ahead and save just in case. So let's go ahead and add the first cutout, the flat cutout. So I'm just gonna go ahead and start a sketch on this face. Start a sketch. So I'm gonna right click and click the normal to. So I'm normal to my sketch plane. So I'm gonna just sketch a line here. Make sure it's horizontal. My horizontal constraint is toggled on. I'm gonna use smart dimension to dimension that line to the bottom edge, the circle. So if I just select the smart dimension, select my edge, my line, select the bottom edge, it's actually gonna dimension it to the center of the circle, which we don't want that. So I'm gonna hit escape. I'm gonna hold the shift key and select my bottom edge. As you can see, it shows now we're able to dimension to the bottom edge. So that dimension is 0.197 inches. And so I want to make sure I have a close sketch when I extrude cut the flat. So I'm just gonna go ahead and convert. Instead of redrawing that circle, I only want to select the arc where it's coincident with the line. So I'm gonna go ahead and convert that sketch. And actually converts it to my plane. And since I don't need the whole arc or the whole circle, I'm just gonna go ahead and trim what I don't need. So I don't need this line. So I don't need this line. I don't need the rest. I only need the sketch. This will be my profile to create the flat cut. And it's so sketch is black, so it means it's fully defined. So let's go to features, extrude cut. So we're going in quarter of an inch. So 0.25. Check. Got our first cut. So looking at this makes me think, well, maybe I should have done my chamfer after my cut. So actually I can just drag my chamfer over and let me do that because the sketch is after it. So actually let's mirror that and let's go back and delete our chamfer and create it again and see if that works better. Go to my extrude cut. So just like I talked about before, that's why we did a both end, my extrude boss, if I edit feature, we did the mid plane. So it's symmetric about that mid plane. So if I go ahead and I mirror my feature about my right plane, it's perfectly symmetrical. Instead of having to go back, start a sketch on that face, and redrawing it, you just mirror it. And that's where design intent comes in, right? You want to think about how you design the part so you utilize the features. It's easier for you to build it, so you're not going back and redrawing sketches that you already made. So the only thing we have left is the cut in the middle. So I know I need to start a sketch on a plane. It's really not the midplane, so I need to create a plane. So go up to reference geometry, get plane. So I'm going to click on this face. Let's flip the offset. And it's 2.392. That's where I'm going to sketch. Okay. You can make this plane bigger if you want. See it better. Perfect. So I'm going to start a sketch on this plane. Select it again, click sketch, and I can go normal too. And it's the same profile, so I really don't want to go back and redraw it. So I'm gonna utilize the convert entities again. I'm gonna select this, work, and that edge. I'm gonna convert those, and those are converted on that plane. And as you can see, they're fully defined because they're driven by this sketch, and that sketch is fully defined. So if you change that sketch will automatically change. So I'm going to go ahead and extrude cut that, create the flat in the middle, and that is 2.947. I'm just going to let SolidWorks do the math. Minus 2.392, so it's 0.555 inches. Check. And we are all set.